LexisNexis is probably the coolest name because it rhymes. LexisNexis. You could just say that a few times. It's like my buddy, he's trying to think of a name for a startup right now, and I told him that Data Double Check is a good name.
That's
It rolls
pretty
off the
good.
tongue, right?
It is. It is.
And
It
it's
is
to
pretty good.
verify your data. That's the whole like point of
I
the
mean,
company.
honestly, I got it right from the name. That makes a
Boom.
ton of sense.
Data Double
I
Check.
think there's a new consulting. There's a new consulting business for you now.
Yes. I naming? Dude, should I go?
Naming.
They have startup naming like consultants.
I have heard, yeah, like branding and stuff, but I just think you can just simplify it.
Yeah,
You
just
can.
the
This is
name.
your space to disrupt.
Yeah, and I figure out if the URL is, or if like the domain is free,
Yeah,
and yeah,
let's go for it.
I'll give you all that kind of stuff. All right, anyways, today we talked to David Bayliss from LexisNexis Risk. Dude, what'd you think?
It was an awesome conversation. David is kind of like an unknown legend to me because for those who aren't familiar, and you probably aren't, he is the chief data scientist at LexisNexis, which is a company that definitely has your information and is using it to power all sorts of use cases, like how you get your home loan, how somebody does a background check on you, how somebody figures out, your address for validation for whatever it might be, your bank or anyone else. And he has been there for 20 years and started off doing very low level computer programming work and has used that now to help make the world of large scale data science for individual verification a lot better. What
Yeah.
was your main takeaway?
Well, they definitely have your information, but in a good way. Like I want
Yeah,
these guys
I
to
hope
have
so.
the information after hearing what David was talking about and how he thinks through these really difficult problems. And I thought he's awesome to listen to. He's just funny in the way that he doesn't try to be funny, and then he just has these incredible moments where you realize he did not try and crack a joke or anything, but that was actually quite quite funny the way he said that. And
Very
he
British
was
sense
like
of
one of
humor.
those. Yeah, exactly. Like I appreciated that piece of it, and it's that British dry humor too. So, but coming
Hmm.
back to like the content that we were talking about, I found David just off a whim from some LinkedIn posts, and it was very random. I noticed a LinkedIn post where he dug into some of the stuff they're doing, and we get into that in the conversation. But really, like when I saw this LinkedIn post, I realized that it was not your run of the mill like intro to MLOps post. And he talks about this low level stuff. He also talks about why he's got PhDs that are doing so much of the low level stuff. And then he doesn't even want the data scientists or the ML engineers even to be messing with any of that low level stuff. They're throwing, what did he say, like a dozen or more PhDs just to figure out how to make things run faster and smoother and more securely. And when I followed up with him after the talk, it was funny because I was like, "What should we like name the talk that we had? Like, what should we have the title of this be?" And he was like, like data governance, security, and privacy. It's not really the sexiest clickbaity thing that we could do." I just thought that was like a testament to how funny he is. Like he doesn't even try to be, but he is. And so yeah, that's it. Like I encourage everyone to check this out. Like listen to this one. This is one that I feel like I'm gonna go back and listen to a few times just because there were so many gems and so many things he said. That 20 years of deep focus in the field, it comes out here.
I totally agree.
So with that, let's get into it. And before we do, I want to mention that if anyone has any recommendations on how we can make this show better, please reach out to us. We're always looking to know what we can do to make this more engaging, more interesting for you, the listener. And it would mean a ton to both Vishnu and I if you share this episode with one friend that you think might be interested in what David has to say. All right, let's jump in. Let's start with LexisNexis and your role in LexisNexis and what you're doing there.
Okay, LexisNexis is really about risk analytics. Whenever someone's taking a risk, they want the most and best information they can to make the best informed decision they can, and that's where we come in. So you'll see this in financial markets. When you take out a bank account, you probably went through us. If you ask for credit, it probably went through us. When you log in and your app wants to know, is that really you on the end of your phone? That probably went through us. When financial transactions go between banks and they're trying to make sure they're not doing money laundering, that probably went through us. In the insurance market, if you reach out for an online quote, that probably went through us. When someone hires a school teacher at your school and they want to make sure this isn't a sex pred that's hiding, that probably went through us. When you go to your favorite TV show and they say, oh, I just want to find out who's in this area and what they've done and what their background is, that will have gone through us. When they're checking whether or not your kid is the actual kid taking the exam, that probably went through us. So really, we are about 40 milliseconds of everything you do that matters. And that's really the key thing that I'm hoping to get out of today. There's lots of cool stuff and fun stuff out in the ML space and the AI space, but my job is to be the most boring person on the planet and to get the answer right when it really matters. And I'm the chief data scientist for LexisNexis. They didn't know what to call me 20 years ago because they didn't have the term data science. So I've been the data bunny, the data alchemist, him that does stuff, or you. I mean, anything it takes. But my job has always been, how do you actually take the data and integrate it so that you can deploy it against a problem?
So many questions I have there. And I think one is, you've been with LexisNexis for 20 years. I want to hear about the evolution of those 20 years and what you've seen change since you've been in data that whole time. But also, like, there's so many use cases, and it feels like that. How do you even deal with all these different use cases? Is it templated under the hood, or I feel like you can't template all of this. These use cases are so extremely different, and so maybe we can start with that and then go into the evolution of LexisNexis and especially your evolution in the data field.
Well, I actually have a painfully simple answer to how do you deal with all the use cases, and that's you just ignore them. They don't really matter, because there are so many use cases and they grow so far and they have evolved so much over time that the one thing you learn is that the use case that the product manager thinks he has today is completely irrelevant to what he's eventually going to want my system to do. What doesn't change is the data that's coming in. So my approach is entirely focused upon the data. Collecting the data, integrate the data. What is the data actually telling me? What is the truth? And then once I've built up my world model, they can ask whatever questions they want and we can just answer them from the model.
I gotta say, I love that perspective of saying, well, what they're saying to me now isn't what they're going to say to me then. And I have to focus, or then meaning in the future, right? And I have to focus on what will always be around, which is the need for high quality data, understanding the data, and making sure that we have rational ways of organizing, categorizing, and quality checking that data. And just to provide the listeners a little bit of context about the scale of data that we're talking here. Looking at the company's websites, the company's statistics that we pulled earlier here, LexisNexis has 1.9 million new legal documents that are added daily from 71,000 sources, generating 137 billion connections. Nexis News includes over 39,000 premium sources. LexisNexis content includes more than 273 million court dockets, over 148 million patent documents. I could go on and on and on here. But just to kind of give the listeners a sense of, this is an incredible amount of information that has to be organized and turned into a useful almost graph that can support a number of different use cases. And my question to you, David, here is, how, as the chief data scientist, do you play a role in the way that the company thinks about data and structuring data as the tools for working with data change?
We kind of have it split. I like to think of it as a healthy schizophrenia, in that my job as the chief data scientist is to make sure that the data has integrity. So you spoke to part of our scale, but that's in fact the smaller part of the company. The bigger part of the company has 250,000 different sources, and we're bringing in billions of records every day, 1.2 petabytes consolidated weekly. It's huge. It's absolutely huge. My job is to make sure that we have all of that data organized in a way that the data scientists can get at. We have literally hundreds of data scientists that are specialized out into all the different verticals. So, way back in the day, 20 years ago, I actually was what I would call a real data scientist. I would go and talk to the customers, I would find out what their problems were, and I was actually developing solutions for a real customer. But as time has progressed, and we're in like 150 countries, and we have people now working in research departments in medical fields. There's no way I can understand PhD level discussions in 20 or 30 different fields. So we employ the actual data scientists who go out and solve the actual customer problems. But my job in the background is to make sure that the data is integrated. But the other thing we haven't touched upon is regulation, in that if you imagine the data we have is incredibly sensitive. It is ridiculously sensitive. We know way more about people than you would ever want to be publicly known. And therefore we operate under a very large number of regulations. And a lot of my job is actually making sure, not that we have all of the data about you to answer a different problem, but making sure we only have that data that we can legally make available in that situation. And that can differ by customer. If you've given one set of permissions to one bank and another set of permissions to another bank, and then you apply to both banks for a loan, they actually have to get different answers back. That's the law. And making sure that that complex dance happens correctly is where I come in. And specifically, we work at such scale that the little tools you see out there literally just fall over and die. One of our main feature extraction routines, it creates 120,000 features based upon logically joining 720 files together. Well, you go up to your favorite SQL system and give it a select statement with 720 joins. You will probably actually crash the SQL server. You certainly won't get an answer back in 30 milliseconds. So my team has actually built the tools to allow us to do that work at the scale we need, and I'm hoping we'll come on to later, also with the longevity that we need, in that we're not a little startup that's here to make a quick bang and then, get out fast before the excrement hits the fan. We've been around for decades, and we plan to be around for decades, and so our solutions have to be able to be resilient over decades.
Well, first off, I just want to compliment you on making the saying "shit hits the fan" sound so much better when you use excrement. I think that's great. Second of all, there's so many places that I want to go and so many things that I would love to talk about with this, because it must be, I'm guessing that you're doing everything on premise. Because of I just feel like if you were doing it in the cloud, it would be really, really expensive. But you can correct me on that. And then the other thing that I want to touch on is data management and just data access, with the ability, like, how do you know which data scientists have access to what, and how do you control that? Have you built internal tools for the data access also?
Yes. Okay, so tackling first, we are currently on premise. We actually built a supercomputer system, a lot like Hadoop, but almost a decade before Hadoop. And we have been running that on premise for 20 years now. And for many, many years, we believed we had to stay on premise because it wasn't really feasible up in the cloud. I mean, yeah, a big batch process taking 1.5 petabytes of data, spitting out 150 terabytes of compressed keys. That's like an $80,000 process. And then you've figured out you've got a bug on the third line and oops.
Yeah, exactly.
Now, in fact, I have come up with a plan to solve that. So we are migrating into the cloud. But data access. So the core there is metadata. Now, metadata is used way too much, so let me explain what it means. We can't afford black boxes. Most of our stuff, as I say, we're making decisions that are going to affect your life, and if you don't like the decision we made, you're going to call up someone and whine about it, and we have to be able to defend that decision. So just about everything we do is highly explainable. So our algorithms are effectively encoded in a DSL, in a meta language, so that then all the way from the model, we can trace all the way through to the data, what data was used, why it made those decisions. Many of our algorithms actually have to be registered with a state or with a customer, so that then when their customer calls them, they can defend it and say, well, no, I'm sorry, but you got this conviction on this date and that disqualifies you from this role. Now, that same metadata that allows us to track a query that's happening in production also allows us to track the data that's going to an individual data scientist. If you imagine when a data scientist is doing something, whilst we all love to pretend it's blue cloud and blue sky and what have you, the fact is they're going in on a mission. They have been told they need to discover something for some customer. And based upon what they have been told they need to discover, we're going to know what kind of data they're going to be allowed access to. And that is therefore, in fact, filtered through the algorithms. So if you imagine, you code up with your algorithm, and you actually provide a permission block that comes from our security systems that say these are the security rights you have when you're accessing this data, and the data that actually comes up to you has then been filtered down to that which you're allowed to have in that situation. Does that make sense?
It does make sense. It does make sense. And I think what I really appreciate there is how you've laid out in the last sort of few minutes here, at a high level, what kinds of unique challenges of scale, use case, and I think diversity that LexisNexis deals with, right? You're working with an incredible amount of data, you're working with highly sensitive use cases, and you're working across a very diverse range. And what I would really like, our audience tends to be, I would say, practitioners that work in smaller teams of data teams, right? Usually, like, for example, I have primarily worked in teams of 1 to 3. Many of our listeners tend to be, I would say, up to teams of about 20. A lot of people working in startups, growth stage companies, and even the public companies that, I think our listeners tend to be a part of, the data teams number no more than 20, 30, maybe even 50, right? And I think you're talking about a sort of level of sensitivity and, frankly, maturity, given the fact that you've been a part of these efforts for 20 years, that many of them can certainly learn from, but maybe not relate to. And so what I would love to talk through is the perspective of like a single use case or a single data scientist, kind of walk through the flow that they might have from being assigned to a use case and ultimately deploying, evaluating, and then monitoring an algorithm for success. How does that sound?
Yeah, I'll have to be vague in a few places because we might think we have a bit of secret sauce in there, but
Sure, totally respect that.
Let me think through. I'll go with one of the very, I hope, easy to relate to cases. I talked about the fact that we work in the insurance space. If you think about it, the idea of insurance is you come along and you think you drive badly, but you think you can persuade the insurance company you drive well, and therefore it actually makes good financial sense for you to pay $300 a month, so that when you write off your BMO once a year, they pay the bill rather than you. There is a sort of vanilla insurance algorithm that can give a generalized rating for you. But if all of the insurance companies use that same vanilla algorithm, where's their value add? How do they make money? What, in fact, they're going to sit around and do is they're going to decide there's some part of the market that's sweet, where at the moment the other insurance companies are billing that too high, and they can take a slightly more aggressive play, and therefore that's what they want to do. But obviously they want to know how much that's going to cost them, and they want to know just how wide they can open the net for what degree of risk. So typically they're going to want a custom model. So they will come from marketing department, or the bigger companies will have a individual sales person attached to them, and they will say, we've got this analytics opportunity, we want you to provide us a better model for cost coverage for this. And a particular data scientist will be assigned, and they will be told initially the customer is willing to give you the following amount of data with outcomes. Now, the particularly interesting thing there is that you will actually get differing outcomes by company, because the way, that's actually an important point, the way your model is handled also impacts the outcome of the model. So, for example, if you have a set of people who respond to an insurance claim by just telling everyone to naff off, and 2/3 of the people actually take the naff off, then you're going to actually have a different cost response to that model than some company that goes out of their way to say yes to everybody and automatically writes out the check. Right. So the moment you actually get specialist training data, that changes it. So this data scientist will now have that customer data. They will put that customer data through our normal cleaning and linking processes, and they will pick a date. Because remember, we're doing predictive models. So they want to be able to prove to the customer that this would have worked. So part of our magic is our system can't just produce all the data of the day, it can produce the data as of any point in time over the last 10 years. This is how this thing got nicknamed the Tardis. We can travel through time. So we wind back a year ago, and we produce the data dump that we would have produced for these people a year ago, and they now do that with their outcome data, so they can say, this is what we'd have had, this is what we're trying to predict. Now, at that point, if you imagine we've got a balancing act, in that on my side, and this is why we have what I call a healthy schizophrenia, I have to be so locked down and uptight I squeak when I walk. But you want the data scientists to be creative, and you want them to be open. So we don't typically restrict what tools they use, but they're in an iron box. They can't get any data out of that box. They can do what they want in there. They can produce an algorithm, but they're in an iron box. It stays there. Then once they think they've got something marvelous, and they normally do, they have to code that up in my meta language. Once it's in my meta language, I know exactly what it does, and this thing can then be picked up and moved back to my side of the world, where it can be executed in a production environment, and we know exactly what data it takes into account. We can absolutely guarantee it's not penalizing any of the groups we're not allowed to penalize, and all of that kind of good stuff. So that is that typical cycle. Now, I can't really tell you exactly what they're going to do. Some of them will fire up Python. I think a few of them still use SAS. Some of them fire up RStudio. Now we're in the cloud. A few of them have got a love affair with the Amazon thing that does various magical bits. But as I say, we have hundreds of these people. So you'll hear me say very often, and it scares people the first time they hear it, I specifically don't care what it is they're using to do their experimentation, because the moment I care about that on my side of the world, the universe just ends, because I've got to keep track of all these different things and we're stifling innovation. What I care about is that whatever they do can't get out the iron box, and once they do have something useful, we can move it back onto our side where it comes back under regulation.
Damn, so this iron box, I mean, you hinted at Tardis a little bit. I think we should go into that now. That's a great segue into what exactly it is. I loved this whole conversation started because of a LinkedIn post that I randomly saw where you were talking about Tardis. And basically, I have a very minuscule understanding of it, and I really wanted to talk to you more about it because it seemed so fascinating and it seemed very different, but also a little bit visionary, if I can use that term, as to how to do something like this. And let's just start with like the basics. What is it, and what does it do?
Okay, well, let's start off with the analogy. Are you familiar with the Doctor Who show? No. Okay, there's a sci-fi show you need to have watched. There's an old British sci-fi show where the guy would go into a little British police box and it would shake and rattle, and then it would reappear at some different part of the world and in some different time. And through this he could travel through time and he could travel through space. And each episode he would typically, because it was an old British show, he would pick up some pretty girl along the way, but the important thing was there'd be some new collection of bad guys and he would shoot these new bad guys. But the idea was that the TARDIS allowed you to be the same. It was exactly the same lead actor each time, but he could travel through time and space. The idea behind the TARDIS was we wanted a way for our IP to be able to travel through time and space. Now, what do I really mean by time and space? Well, the first one I've already alluded to. I've been playing this game for 20 years, but I'm the new boy. We have products that were started before I was born, and they're still being used to the rate of hundreds of millions of dollars a year. So, we are in the very long haul here. We have customers we still support with a mainframe in the basement. We're around for the long haul, but my kids work for the company. I want this working in 50 years' time. So there is very much a view. Other thing is, you say you got lots of people who work in startups and that sort of thing. We buy dozens of startups. And I would guess 2/3 of them, 3/4 of them, are going through a technology refresh when we pick them up. And it's normally because they're going through a technology refresh they finally work out isn't going to work. That's because when they do the startup, they go out there and they gather all these really cool third-party tools, they glump them all together, they burn them into their code, and then 2 or 3 years down the line, some of those third-party tools are no longer as wonderful as they used to be. Just go and look at the Apache Attic and look at Apache, was it Apex? This was the world's best batch system 3 years ago until they got into a fight and no one ever supported it again. So the notion behind the TARDIS is we wanted a layer of insulation so that I could gather together all of the best third-party tools on the market and we could deploy them, but we could switch between them at a moment's notice. And when I say a moment's notice, I literally mean we have quite a few processes which will be using one set of third-party libraries in test, another set in QA, or 3 or 4 different sets in QA, and then actually get deployed out using different ones in different verticals. That is how psychotically I take this notion of being portable. So you've probably heard of JDBC, and you think, that gives you Java portability. Well, it doesn't really, because the SQL syntax is different between each of these things. And if you think it's portable, take a piece of SQL through JDBC hitting MySQL and try to port it to SQL Server. Or try to port away from Oracle. You will die. We have spent literally millions of dollars sometimes because some of our old kit was burnt into a SQL database that no one was supporting anymore. Well, with the TARDIS, none of that's true anymore. We actually have a complete abstraction layer in there. So the notion of a database is completely separated away from the implementation. So we have exactly the same code hitting SQLs, NoSQLs, in-memory databases, caches, you name it. And that's really the idea behind the Tardis. It completely abstracts out this notion of your data algorithm from the implementation of the data algorithm on any particular set of hardware.
So does that make it slower? Like, is it a translation that's happening? Is it it's just like as it has to go through that, or is that all done beforehand? Like, what does that look like?
The DSLs, where the metadata is, they are effectively compiled at application load into a set of in-memory data structures. So you do take a little bit of a hit on application load, although we have some magic there I can talk about if you're interested. But once the application is loaded, there is a little bit of translation overhead if you actually got down on your hands and knees and actually measured it. But remember, there's two factors going on here. One is, yeah, technically there is a translation layer, so it must be costing you something. But I've got a team of a dozen PhDs who are coding the low-level access routines, and 3,000 people who are now using those access routines. How many times do you think those 3,000 people would have actually written low-level code as well as my dozen PhDs I got over here? And the answer is it hasn't happened yet.
Yeah.
So in fact, what you find is that you get net performance lift because what's happening is your low-level access code is being written by people who can now spend the time to actually get it right, and the data people focus on the data. It's sort of really, if one's honest, back in the day, yes, I am that old, you used to have your IT team and you used to have your modelers, and between them they used to do MLOps back in IBM 370. Then someone discovered that in the big data world that didn't work, so we joined them together in this unicorn that was called a data scientist, which was lovely, but not many people are actually weird enough to have degrees in computer science and math. I am one of them, but thankfully not many people have my mind. But this became popular, so over time lots of people started calling themselves data scientists, but they don't really have those low-level coding skills. I mean, just look at how many of them are using Python, and it's like, you're convincing me you've actually got low-level coding skills and you're using Python. Yeah, I'm not thinking so. So we've sort of split it back up now, so that we've actually got the people who really are genuinely doing fantastic work understanding the customer problem and turning it into a data problem, and then we have the people who are taking the data problem and turning it into something that can absolutely fly on modern architecture.
And so one way that I think that you had mentioned it before is it's like a JVM, but for data science?
Yeah,
is that correct?
That's a way to think of it. In a JVM, things like get instruction, put instruction, write to disk, read to disk is handled by the JVM. We have a data science virtual machine. So in that virtual machine, you can fetch records, you can send records, you can read records, you can write records, you can index records. I mean, in fact, the thing has grown even since those LinkedIn posts. So one of the things we found is literally just moving data from one place to another takes an astonishing amount of time. Reading it in a particular format off disk takes an astonishing amount of time. So we've moved all of those sorts of things down into this data machine. So literally now, when I'm doing data work, I do it on, I'm going to pick up the screen and shake it, I do it on my laptop. I can do huge big data work actually on my laptop with all of the advantages of local editing and all of that kind of stuff. And then I can just push a button and it goes up into the cloud and it's now processing tens of terabytes of data using completely different underlying implementations, but it just works. And that is the beauty of the data science virtual machine.
I wanted to go back a little bit to that point about the Iron Box and understand a little bit what that actually means. And sorry if I missed anything here, but the way that I understand it is the data scientist, as you have put it, as an experimentation period, and once they think they have something, as you said, it goes into a format that is then converted into your specific DSL and allows you to run the sort of quality and implementation checks that you need to make sure that it can actually be used in production. What do you mean by Iron Box? Like, what does it actually look like?
Well, I mean, these days it's actually up in the cloud, and I frankly don't know all the things our security team do. I know that they get audited hundreds of times a year, but it comes down really to setting up the policies for the subscription in such a way that data can only get in and out in defined ways, and that the users don't have access to change many of the attributes of their subscription. Frankly, the way that we sort of described this to them was laptops in the sky, and that is sort of what it is. It's their laptop, they can get at the data we show them, and it isn't really a laptop, obviously, and they have some amount of scratch disk that we thoroughly scrub when they're done with it. And, you know, that is really what the Iron Box is. It's a very tightly controlled sandbox environment where security and audit and legal and everyone has sprinkled enough holy water around to convince themselves that data is not getting out of there.
Got it. So this sounds a lot like sort of, I guess you could call it like DevSecOps, or just in general. Oh gosh, I don't know why I'm even trying to jargonize this. Basically, it's a safe place where once data scientist has an algorithm and some data, your IT and security team can make sure that algorithm can be then turned into a high quality system that a client can use with the right performance.
But then for it to get out of that box, you have to basically do a translation so that there's that metadata that comes through, and so you can always go back in time, and you have that lineage for it, and you have the ability to trace it. And I imagine also when you're doing the metadata, does it like scrub PII, or is PII already like way out of the question when it gets into the box?
There's a few different answers to that. Not being awkward, but it depends exactly on the situation. In the commonest case, we have something internally called a LexID, which is a unique identifier that we can actually use to tag an individual. So you may remember I said the data comes in from the customer, it will have had PII on it, but what we do is we take off the PII and we put our own internal ID on there, encrypted with a one-time key, so that we can then actually treat that as if it has non-PII. Now, the other thing, Vishnu, you've mentioned testing a few times. One of the things that we do for the quality side is very often the training data is not complete. What do I mean by that? Well, suppose I've trained a forest against this data, and the forest comes popping out. You've got all of these decision points in your tree. Now, you know how those decision points actually impacted the data you have, but what you don't have is a coverage metric. If you think of something like Java, when you're testing your Java, you know how many lines of the Java actually got tested. You don't know when you train a model how many of those decision points inside your tree were actually impactful. But because we have the tree actually encoded in metadata, we can now hop to the other side and actually generate fake customer data that would exhaustively test the tree and push it back, and then say, this is what you think you gave us, is this what you actually wanted? And we have found quite a few times that has actually identified holes in the training data. So that's why I said it depends when it comes down to PII. Now, we also have a few other tricks in the area of differential privacy, in that, are you familiar with differential privacy?
A little bit, but it would be helpful to have an explanation from your perspective.
The idea of differential privacy, and I wrote a paper on this called hairy kneecap theory back in the early 2000s. And the idea of hairy kneecap theory was that I could set up a camera at knee height just to track everyone going around the building, and I could know what everyone did, And because the number of hairs on your kneecap is unique, I could identify individuals uniquely, even though I didn't actually know who anyone was, because they couldn't identify their kneecaps. That is my slightly whimsical version of differential privacy, but it is something that impacts us, particularly once you get into fraud analytics. You're working out at the end of the bell curve. So you have to make sure that even things you don't think of as being PII actually can be PII. There are first names which on their own are actually PII in this country. So we can actually be more private than PII because we have effectively the dictionary. We know everyone in the country. We know for every person how little it takes to identify them. And therefore we can avoid anything that would actually identify them being attached to that data.
Yeah, I was thinking about the, who is it? Elon Musk's kid's name is one of those. I think that is a is a unique identifier just because of how it is. So, oh, wow. And also I love this hairy kneecap theory. I'm going to probably tweet about that later. It's a great one. Now, let's jump into this other post that I saw on LinkedIn and that I'm very intrigued about, and it is you speeding things up. And you, if there's one thing I've learned, you are you're making sure that things stay fast, and you're making sure the right people are tasked with the right jobs. A data scientist isn't going to go and try and speed things up with their Python. You got to get the PhDs who can work at that low level to speed it up. You, I think, from what I gather from this story, you were one of those people trying to speed things up, right? And you were able to do it by breaking the rules or changing the rules, I think was my favorite part of the story. But can you give us the whole context here?
Well, there were a few of those I put out there, so I'm not sure exactly which one you're referring to.
Do you want me to jot your memory?
Was this the one on the linking, the giant memory linking?
Yes, exactly. Anonymized linking, exactly.
Okay, well, let me tell you the bit behind the speeding things up, then we can go into the linking if you want to. Normally, one of the things you're thinking about when you're trying to optimize something is how big a query space do you have? If you have a very limited query space, so people, at the simplest, if people are only ever going to ask you one of 5 questions, you can do all the work to pre-compute those 5 questions and then hand out a canned answer. Now, when you come into search, which is the particular thing I was dealing with there, the logic has always been that you can't use pre-canned answers for a search, because there's an infinite number of possible search tokens. You know, you go into Google, you can type in absolutely anything, and therefore you can't pre-compute search results. And that was static theory, and to my chagrin, there are even videos that my team insist on playing while I was hammering this into newbies 15 years ago. But as I was going through this one, it occurred to me that there's multiple types of search. There's the search where you really want to know about a range of things. So, you know, you've gone onto Amazon and you're trying to find a gift for your wife or something. But there's also the search where you're specifically looking for a particular thing. And linking and matching is a search where you're specifically looking for a particular thing. Now, the little epiphany I had was if you're looking for a particular thing and we have the universe of people, then in fact there are a limited number of queries. There can only be one entity that you're looking for, so I can reverse the problem and I can say for every one of my 400 million people, what are the valid ways that I would let this person be searched for? And then I can actually pre-can all of those answers. Now, if you want to generalize that and view it in terms of a model, you need to know what part of your model is your customer sensitive to. In that you think, well, I've got this whole model, but very often either the ends of the model they don't care about or the middle of the model they don't care about. Now, for search, it's even better in that everything to the left of your first record they actually don't care about. They don't care how much they don't care about a million other people. They only care about the persons they're searching for. And therefore, I could effectively throw away all of those vague responses and all of those, well, no, maybe kind of responses, and I only had to pre-can the ones that they were actually going to get hits on. And that is how I solved that particular problem. And I mean, the speed up there was utterly ridiculous. I think it was an order of magnitude reduction in latency. I got down to about 3 milliseconds, and we were pumping 40, 50,000 transactions a second. And we're actually doing better than that now.
That's a really fun story. I think what I like about that is it sounds like what a lot of people in the data science and engineering deal with day to day. And that is, you're given a very sort of loose problem where the demand is for a lot of impressive technical work to some degree, right? And the sort of charge that you're given is, hey, go make something miraculous happen that that has never happened before, right? And I think that a lot of people start with that approach and say, okay, I'm going to try and develop the best technology possible for the situation. But I'm reminded of what Jeremy Howard, who came onto our podcast from Fast AI, said maybe a year ago at this point, which is said, if you want a problem really solved, give it to someone who's lazy, who doesn't want to do that work, and they will find a way to define the problem in such a neat way that solves exactly what it is you need to solve for, and does not much more. And that's the way I think that, I have heard in a lot of, programming books in general, to be a much more efficient approach, as demonstrated by the example that you're doing here. And I think this has been a great conversation thus far. We've talked a lot about what LexisNexis has done. We've talked about what the machine learning and data platform looks like at LexisNexis, talked through a little bit of use cases. Where I'd love to take it next is to talk a little bit about your experience as a data professional for the last 20 years and what lessons you've learned along the way, probably for longer, as a data professional during that time. And the first place I'm going to start with is what is it that kept you working at LexisNexis for the last 21 years?
Well, I'm obviously a geek, but I'm a geek that can impact the world because I'm working at LexisNexis. I mean, I don't know how much you've looked into the history, but my very earliest work was after 9/11. We actually worked with the various American agencies tracking down another 80 terrorists that were in the country that no one had. Well, I'm not going to go to some company and start finding ways to sell soap better when I actually have a chance to keep the country safe. There are literally serial killers that were put behind bars because of the technology we've created. Even now, it's our systems that are going out there tracking down missing kids. There are people out there who are getting credit that wouldn't normally because we have systems that can actually give them credit for the way they behave. And I mean, if I want to be a technical geek, we also have by far the biggest and most complicated technical integration job on the planet, bar none. So if I believe in what I'm doing, this is the place to do it. And I mean, I also have to say, for me personally, as you probably detected, I'm not your typical big company gray suit. I'm a little weird, I do my thing, and I'm going to do it my way, and I want to be surrounded by the best when I'm doing it. And Lexis is a big, great company, but they have been prepared to really build this little environment in which I can do my thing, and I can do it to the best of my ability, and then they do their thing all around me, and the end result is just fantastic.
I love the way that you frame that, because I can actually attest to some of that impact that you're talking about. What my company, which is a LexisNexis user, which curiously enough occurred after Demetrius decided to do this podcast, does is work with seriously mentally ill individuals. And part of what we have to do is figure out where those individuals are. And we use the stuff that Lexis has to help us find people, use public records effectively to identify where they actually are, not wherever we get the listed address, which tends to be stale. And I think hearing you talk about your motivation for sticking it out at a place with such tremendous impact is really awesome in an age where we have seen more mobility in technical careers than ever before, right? The average big company tech worker stays for about 1.5 to 2 years nowadays. And there's a lot of reasons for that, but the opposing side of it, which you've talked to a little bit, is that, the opportunity to make a lot of impact, work at scale, and solve interesting problems. It certainly does, I think share an important message. And Demetrios has something here that I can tell from his face that he wants to say, so I'm going to kick it to him.
Well, yeah, I mean, this has been incredible. We got to wrap right now, but I'm so thankful, David, for you to come on here and tell me a bunch of shit that I had no idea about. Like, I learned a ton, and I also am just like, every time I would hear you talk, I would get 5 more questions. So it's almost like I want to do a round 2 of this, because especially at the end there when you're talking about some of this stuff, and I know it's also of interest to you, is the ethics of what you're doing and how you're going about it. I mean, you've stuck around, you've been able to go and do some really incredible things, as you said, with like capturing terrorists or making sure that serial killers get put behind bars. And I imagine there are deep ethical questions that you have to face on a day-to-day basis, and so I want to dig into that. I want to dig into more of like just how you're optimizing more of your setup, the homegrown solution that you've got, and how you were able to move to the cloud, what that looked like. There's so many good things. So if it's all right with you, we'll just cap it here, and then we'll try and do a part 2 sometime in the future.
Sounds fantastic. Thank you for your time.